Hello viewers, welcome to another lecture by Martin Tutorials. We're going to be doing combinations. I have taught it before in other videos and I will put links in the description. I think it is helpful if you watch those before that because I will be using some theorems which I talked about, though I will be explaining it here. And here's our scenario. We have a factory with 11 workers. To make it simple, I name them A, B, C, D, E, F, G, H, I, J, K. If you want me to use 11 names, put in the comments. I'll redo it with those 11 names. If that makes you happy. But I think it's simpler just to call them that. And the question is, we have to order them. It's some sort of assembly work where they have to be in an order. But there's one condition. 4 of them, A, B, and C, D, must be together in any order. It might be C, A, B, D, it might be D, C, B, A, as long as they're together. And the question is, with this restriction, how many ways can we order these factory workers? Now, without that restriction, straightforward 11 people. It's simple, it's 11 factorial. I taught that before. That's the number of ways of ordering 11 objects or 11 people, which is 1 times 2 times 3 times all the way until times 11. You work that out and that's the way of ordering it. But we have this condition, A, B, C, and D must be together. To begin with, I treat A, B, C, D as one concept. Like, I'm making up this term, I'm calling it the bubble. That's the A, B, C, D bubble. And you've got others. I'm making up an order E, F, G, H are here, and let's say K and J. I'm A, B, C, D, E, F, G, H, that is I, except there we go. I, J, K, they're all there. That's just one example of ordering it with A, B, C, D together. Now, for every order, there's many ways of doing A, B, C, D. Now, the way it is here, if I treat this as one concept, is 1, 2, 3, 4, 5, 6, 7, 8. That's 8 factorial. That's not the answer to the question. That's to begin with, treating A, B, C, D as one concept. Now let's pretend we went through all of these 8 factorial ways. I listed, there's one, there's the next order. It'll be a very long lineup. And with each one, with that, what I call that bubble, with every one of those orders, there's going to be 4 factorial ways of doing this, 4 factorial ways of doing that, etc. So just one example, this particular order with this bubble, there's 4 factorial ways of ordering 4 people together. So for every one of these 8 factorials, there's another 4 factorial ways of doing it. So that is the answer to the question. I haven't got the ultimate answer. It's 8 factorial times 4 factorial. And I will admit I cheated. I worked this out ahead of time. It's to save me time and trouble with a calculator. 8 factorial is 40,320, and 4 factorial is 24. And of course, if you with a calculator, you do whatever you're comfortable with. If you just plug 8 factorial times 4 factorial equals, you're comfortable, that's fine. And we multiply those together, and we get 967,680. And that would be the answer to the question in this factory. Thank you for watching, and put in the comments if you have any questions.